What is error?
Error is a measure of the estimated difference between the observed or a calculated value of a quantity and its true value.
Why does it happen?
Error correction is the detection of the error and the reconstruction of the original in the order to form an error-free data.
How does it occur?
An error can be detected or the detection occurs because there is an absence of noise or other any impairment during transmission from the transmitter to the receiver. So the general idea for achieving error detection and error correction is to add some redundancy, some extra data such as from the parity to a message which the receiver can use to check consistency, which will be explained later.
What is an error? Error is a condition where the output information does not match with the input information, and it is due to the noise that interrupts the transmission of data. The noise will affect the traveling binary bits as it may change from 1 bit to 0 or 0 to 1. There are two types of error.
Single bit error, burst error.
This is the example of single bit error, which this data unit is from the sender to the receiver, where in every data unit, for example, the third one in this from the sender is changed from 1 to 0 into to the receiver, means that from the receiver does not receive what is supposed to receive from the sender. So this is the example of single bit error. Burst error, it is due to changes in two or more bits of data unit. So example can be from this example. It can be from 111001111 from the sender. What the receiver receive is, it may be 11111001, and it can be like this. For the error that exists is this one. First, the third data from the third bit from the given data unit from the sender is totally different from the receiver, totally different to the receiver. This is supposed to be 1, and what the receiver receive is 0. And the second one is the fourth bit from the sender is 0, while the fourth one that the receiver receive is 1. So this is what is meant by burst error.
Parity check.
It is the most common and least expensive mechanism for error detection. It can be simple and two-dimensional. So simple parity check is where redundant bit, as known as parity bit, is added to every data unit so that the total number of ones becomes even or odd number.
Alright, so this is one of the example for simple parity check. This one is even parity concept, which is going to check for even ones in the bit. Okay, so first, the example of the data unit is 11000001. So first, we pass this data unit through a parity generator, which is going to calculate parity bit here and then here. So the ones is equals to 3. That makes it odd. 1, 2, 3, right? So because this is even parity concept, we only accept even ones, even amount of ones. So we have to add another 1. When we add 1 in this case at the end, the total number of ones now is 4. which makes it an even number. So the system now transmits the entire expanded unit across the network link. Next thing is it will travel through transmission medium, and then it will go up here to count the bits of the data unit. And now it will check if the amount of ones is even or not, because this is even parity concept. So the total was 4, right? So it is even. So yes, drop parity bit and accept data. This the same concept applies to the odd parity concept. The same process applies to the odd parity concept. So as an example for two-dimensional parity check, let's say that these 4 are the 4 data units given. So first we have to copy all these 4 original data units. The first one first. 1 1 0 0 1 1 1. Okay, so first check the amount of ones for each data unit. 1 2 3 4 5. So it is odd number, right? So if it is odd number, we have to put 1 as a parity bit. 1 2 3 4 5 odd number, so we have to put 1 1 2 3 4. So put 0 because it is even number. 1 2 3, so 1. Okay, not just that, we have to do the same thing but here at the last row. And lastly, we have to take out all these numbers row by row. Okay, the first one must be written in the first place. Okay, including this one at the end. So 1 1 0 0 1 1 1, the same, right? 1 1 1, and don't forget the last one. 1. The same thing goes for every row, and also this one, we put it here. Okay, that's all.
Today we want to learn about CRC, is meaning that cyclic redundancy check. Okay, now we have two code word number 1 and code word number 2, meaning that this number and then this number. One of them is not valid. So how do we check? We have a fixed divisor that is 1011. Code word there is 1 0 0 1 1 1 0. Okay, and the divisor is 1 0 1 1. Okay, now we divide like a normal division. 1 0 1 1, and then we get 0 1 0 because the same, and then we go 1 like this, and then next because it's 0, so we put 0 like this 0 0 0 0. If they are the same number, so we cancel out like this. If same number 0, if different number is 1. So next 1 0 1 1, meaning that it's the same, so it will be all null like this, and 0. If there are 0 remainder, meaning that the code word of 1 0 0 1 1 1 0 is valid. So meaning that we take the fourth in front like this, meaning that 1 0 0 1 is valid. We took this check for the second given code word. Okay, the divisor is the system is same because if we want to check information, we need a fixed thing. So a divisor is fixed. So we start with 1 because it's 1 here. 1 1 0 1 1, we get 0 1 1 1. And then with 0 in front, 1 is backside, so we put 0 like this. And then we got 1 1 1. Then 1 1 1 1 1 0 0 0. So we continue. 1, we get 1 0 1 1. Then we got 0 1 1. If you can see here, the remainder is not 0 0 0. So meaning that the code word 1 0 0 1 1 is not valid here. It's not valid.
Hemming code.
For this example, I'm going to show you 7 hemming code. For 7 bit, there are 4 bit rate and 3 parity code. Why is it 3? Okay, so we have, so this is the formula. So there are 7, 1, 2, 3, 4, 5, 6, 7. 0 is equals to 1. 2 to the power of 1 is equals to 2. 2 to the power of 2 is equals to 4. And 2 to the power of 3 is equals to 8. We're not gonna take 8. Okay, so why is it 3 parity code? Because of this number. So this is the first parity code. For parity 1, the code will be D3, D5, D7 for parity. Okay, so why is it 257? Because for parity 1, it will be skipped 1 bit. So let's say 1, 3, 5, and 7. For parity 2, the pattern will be 1. Sorry, the pattern will be 2, 3, skip 2, 6. So let's say if you have 8, 9, 10, 11, it will be 7, skip 2 number, 10, 11. Okay, and for parity 4, just take the rest of B5, 6, 7.
Okay, assuming there is 4 bit 1 0 1 1. So 1 2 3 4 5 6. 1 0 1 1. So for parity number 1, D3 5 7, we're gonna have number 1, and number 1. So to make this is odd, so we have to add 1 in front. For parity number 2, D3, D6, and D7. This is even, so we're gonna add 0 in front. And for parity number 3, we're gonna have 1 0 1, and this is also even. We're gonna have 0 in front.